All right, so we are in Algebra 2. Today's date is Thursday, February 6th, 2/6, 2020. We're talking about the trigonometric values of special angles. So our objective today is to do what? Sam?
Find the value of sine and cosine of special angles.
That is it. So yeah, we're starting to combine lessons. 2 lessons ago I told you which trig functions would give you which x or y coordinate. Let's see if you remember. So you might have to flip back to your notes. You can give me either way. You can say cosine or sine here. You can say y or x, depending on which one it is. Yeah, Anna?
Cosine gives you x.
Cosine gives you x. And then an easy one for someone else then. Caroline? Sine gives you y. You have to have those memorized first before you can do the rest of this lesson. Okay, so let's review from geometry. In geometry, we heavily reviewed, I shouldn't say reviewed, but we did a lot of special right triangles in preparation for the SAT. So if I have a 45, 90 triangle, if I want to move from the hypotenuse to the leg, if I'm going from here to here, what operation do I do? And if you don't know, look at the poster right up there, right up above Einstein or behind the 3D printers, the top left. In order to move on a 45, 90 triangle from the hypotenuse to the leg, what operation do you do? I know it's printed out small and it's kind of hard to see. What operation do you do? With a quiet raised hand, India?
Is it going to be x squared root of 2?
This length right here, you can think of this as x, and this would be, therefore be x squared of 2. I'm just more asking, how do I move from whatever this length, what do I multiply or divide this length by in order to get this length? So it's that bottom poster where I have the arrows saying how to move from where to where. Can't see it? I can barely see it from back here, but I see it.
It's in red.
You know it.
Yeah. Doesn't it say x to the square root of 2?
It says right here x square root of 2, but
red.
the arrow over there
It
to
says
move,
plus root 2?
divide by square root of 2.
Oh, it's a divide. That's how it's fine now.
And that will give you back to x. And both of these lengths right here are the same, so you can do little tick marks here and here. So if I want to move from the hypotenuse to the leg, I can move that direction too. It's the same operation, divide by square root of 2. There's other operations that you might want to know too, like if I want to go and do the reverse of that, if I want to go from the leg to the hypotenuse, then instead of divide by square root of 2, I multiply by square root of 2. I'm not going to show you that here because it's not needed for today's lesson. I'm only doing the basics of what we need for today's lesson. So in order, like if I'm summarizing what I just said right now, to move from the hypotenuse to the leg of a 45, 90 triangle, divide by root 2. All right. Let's try this next one. If I want to move from the hypotenuse of a 30, 60, 90 triangle to the shortest leg, not to the longest leg, what operation do I do? And yeah, it is up on the poster. Ellery?
Divide by 2.
Divide by 2. And Oscar, while you're over there, how do I move from the short leg to the long leg of a 30, 60, 90 triangle? You can just look right at the poster. To move from the short leg to the long leg of a 30, 60, 90.
On this one?
Not a 45, 90, a 30, 60, 90. So that same poster on the far left,
Divide by 2.
that's how to get from the hypotenuse to the short leg. How do I do it? Go from the short leg to the long leg.
Times square root of 3.
There it is. Multiply by the square root of 3. And I could do the reverse operations, but those are enough. So, question?
Is there a way you can go from the long leg to the hypotenuse?
Yes, it's just doing those 2 operations back to back. So, for example, the long leg to the hypotenuse, I first have to undo, multiply by 3. So undo is divide by square root of 3. And at the same time, I have to undo this one as well, which is multiply by 2. So really, I'm multiplying by 2 over square root of 3 to move there to there. I don't really teach it because you're really supposed to not supposed to, but it's faster to just memorize 2 rules instead of 3 rules. All right, so let's come back to our unit circle. So on our unit circle, this hypotenuse is how long? It's a unit circle. A unit square is a 1 by 1 square. Brian?
180?
This is 180 degrees, but I'm just asking how long is this line right here on a unit circle?
I don't know.
Okay, you can call on someone else. Raise your hands again, everyone that wants to.
I give it to Melody.
Okay.
1?
It is indeed 1. That is the definition of what a unit circle is. It has a radius of 1. Thank you, Beverly. I'll still take your card, Brian. You did participate. So from here, I need to do these operations in order to move from the hypotenuse to the leg of this 45, 45, 90 triangle. What operation do I do? And you just have to look at your notes to the side. Jaden?
I was describing my best.
No, yeah. How do you move from this hypotenuse to the short leg? What operations did we just discuss right up here?
Divide by square root of 2.
There it is. Divide by square root of 2. So that means the answer right here is 1 divided by the square root of 2. That is the length. But, there's always a but, right? We're so mature. All right. So I can't have a radical in the denominator. I need to rationalize the denominator to get rid of these square roots. So how do I rationalize 1 over square root of 2? I mean, that's the right answer, but I need to have it in a slightly different form. So let's come over here and do some notes on the side. 1 over square root of 2. To get rid of the the irrational, what do I do? What do I do to get rid of square root of 2? Does anyone remember? One person remembers.
I don't know.
Yeah, Loria.
You take the square it.
That will undo the square, but I can't square the top and square the bottom because that would not keep this the same number. For example, if I had 1 over 4 and I square the top and bottom, I'd get 1/16, but those are different numbers. So you have to multiply this by 1, something over itself, and still have the same number. Yeah, thank you. I'll take a card. Yeah, Ellery.
Do you multiply like root 2 over root 2?
You indeed multiply by the square root of 2 divided by the square root of 2.
Wait, but also, you know there's like the exponent rule where you can flip it and it becomes negative? Does that work in this situation?
Unfortunately, no. I mean, it does, but it's not very formal. So you could say, yes, this is 1 over 2 to the 1/2, which equals 2 to the power of negative 1/2. And you're correct. This and this are the same number, and that's the same number, and this down here is the same number. But yeah, it's not helpful to us, and it's harder to write also. So we're almost there. I just now need to rewrite this. The top 1 times square root of 2 is square root of 2. I'll do the hard part for you. Whew. And what about the denominator? Square root of 2 times square root of 2. What is that? Another quiet raised hand. Yeah, India. It is indeed 2. And here's the reason. Or maybe, did you want to explain it, India?
The square roots cancel each other out.
You're close. They don't necessarily cancel each other out if I just have 2 square roots. There's 2 ways of thinking about this. First of all, if I have the square root of 3 times the square root of 2, this is equal to the square root of 6. You just multiply the insides. So what I can say down here is square root of 2 times square root of 2 is the square root of 4, and the square root of 4 is 2. That's the easiest way to think about it. There's another way of thinking about it. If I have x times x, that's equal to x squared. So if I have the square root of 2 times the square root of 2, that is the square root of 2 squared, and then the square and square root cancel each other out. I'm left with just 2. Either way, the denominator is 2. We have now derived that this is no longer, we can cross out 1 over square root of 2 because we didn't rationalize the denominator. What it should be is the square root of 2 over 2. That is the dimension of this triangle, the height of that triangle. And this length is also the same because in a 45, 45, 90 degree triangle, these are the same lengths. You can put tick marks again if you want. And I can say this one is also the square root of 2 over 2. So both of them, square root of 2 over 2. But there's more. Because I'm going in the negative direction, I'm going to the left on the x-axis, this should be a negative square root of 2 over 2. Because I'm going up, this should be a positive square root of 2. This is the positive y direction. This is the positive x direction. This is the negative x direction. This is the negative y direction. So whenever you have a negative y, the y coordinate should be negative. Whenever you have a negative x coordinate, the x coordinate should be negative. All right. Let's also derive what's happening over here. So if I'm moving on a 30, 60, 90 triangle from the hypotenuse to the short leg, what operation am I doing? Multiply or divide by what? Add 3? Divide by 2. There it is. So this is 1/2. Done. Now my question with a quiet raised hand, you're going to answer this. Is it a positive or a negative 1/2? Quiet raised hand. Is it a positive or a negative 1/2? Gloria? That's the other one. So why is it positive? What about the y-axis is making this positive? Am I going up, down, from the x-axis? And I can help you. I didn't mean to put you on the spot, but I'm going up. Up numbers are positive, down numbers are negative. And left numbers are negative, right numbers are positive. From the x-axis, I went up, therefore we have a positive 1/2. All right. And then someone else with a quiet raised hand, how do I move from the short leg to the long leg? Someone that has a card. I need more cards in here.
Now that I think about it.
Yes, Emily. How do I? Yep, multiply by square root of 3. So times by square root of 3. So if I multiply by square root of 3, this is going to be the square root of 3 over 2. With the quiet raised hand, is this going to be a positive or a negative square root of 3 over 2? Brian. Yes, why? Positive side of the, is it positive x or positive y? There it is, yeah. On the x-axis, we're going positive. We're going to the right. So that's where all these numbers come from. So more memorization is about to happen. Warning, warning.
No, this is hard.
This represents every single thing on the unit circle that I need you to have memorized.
Not a chance.
So you already have 150 degrees memorized. You already have 5 pi over 6 memorized. Now on top of that, you need to know that this has the coordinates negative square root of 3 over 2 and 1/2.
Why would you remember this?
We're about to see that on the next side of the page. So again, if I now ask you what is cosine of 5 pi over 6, you'll say, well, you'll think maybe cosine. Cosine is the x-coordinate, and I've memorized that if I do 5 pi over 6, it has the coordinates negative square root of 3 and 1/2. Cosine is the x-coordinate. The x-coordinate is negative square root of 3 over 2. So I can, in my head, calculate that cosine of 5 pi over 6 is negative square root of 3 over 2. And I'll do a lot of these examples. So if you're lost, that's okay if you're lost right now.
Dude, what the heck's another? How do you have all this memorized?
I do.
How? How long did it take
Can
you?
we test you?
Yeah, let's test you.
Okay.
I'm
I'm embarrassed if I'll make a few mistakes. Go for it.
Cosine of 45 degrees.
Cosine of 45 degrees is square root of 2 over 2. Are you writing all these down in your homework?
No, these are not. I'm just
Okay.
changing. I'm changing the numbers. I'm changing the numbers.
Let's read them off one by one. Yes, what's this next one, Mr. Sindel?
No.
Cosine of 45.
Oh, I just said that's square root of 2 over 2.
Square root of 2 over 2.
Sine of 11 pi over 6.
Sine of 11 pi over 6 is negative 1/2.
Okay. What about sine of 3 pi over 2?
That's going to be negative 1.
Okay. What about sine of 270 degrees?
Sine of, that's the same thing. It's 270 degrees is straight down, so negative 1.
Oh, cool. Give you a hard one. Sine of 2 pi to the 2 pi over 3?
To the power of 2 pi?
Yeah.
I don't know that. That's
Oh,
not special.
I'm sorry.
I don't think it's to the power of
No, I was
2
joking.
pi.
That's not a real problem. Okay, what about cosine of 11 pi over 6?
Cosine of 11 pi over 6 is square root of 3 over 2. So the way that I'm able to memorize this, and I'll give you guys
Oh my gosh, dude.
some tips and tricks here,
You've been
is
doing this
this.
your whole life.
You're memorizing 5 numbers. That's it. 5 numbers. 2 of those numbers are nice and easy. Are you ready for the 2 easy ones? 0, 1. Can you memorize those?
No.
Yeah.
Oh man, we're in trouble then. The next numbers come from the 45, 45, 90 triangle. Can you memorize square root of 2 over 2?
Maybe.
I just did it. 2 and 2, the top is always the square root. And then finally, the next two that you have to memorize, square root of 3 over 2 and 1/2. Notice that the green, this corresponds to a 30, 60, 90. The yellow corresponds to 45, 45. Oop, that's a 44. 45, 45, 90. And 0 and 1 are when I'm at the extremes, when I'm at these nice corners where it's 0, pi over 2 or 90 degrees, 180, 270, nice quarter rotations. All you have to memorize, 5 numbers. Let me quiz you guys now since you guys quiz me. Everyone,
Why would
stand
you do
up.
that? Why would you do that?
I'm quizzing you on yesterday's stuff.
This isn't.
Everyone stand up. Everyone stand up.
Let me write this down.
Everyone stand up and face forward. Everyone stand up, face the board. We'll do some with our eyes open and then I'm going to have it with your eyes shut. It's okay if you're slow. If it
I'm
takes
wrong,
you 30 seconds
I
to work
quit.
it out, that's okay. Math is not about speed, but eventually we want to start memorizing these more and more. Brian, Beverly, Oscar, stand up, please. Beverly, stand up. Brian, stand up. Brian, stand up.
We're standing
Brian,
in the
stand
family,
up.
Brian.
All right, so with our right arm, and I guess it could be your left, but your dominant arm, you're going to point to a certain degree. So everyone point to 90 degrees. Oh, that was. You don't point like, there it is, there it is. I'm going to point to 90 degrees like this.
Okay,
Here's
that's
90 degrees.
Okay, you didn't explain that.
Yeah, you didn't explain that.
I was like,
Wait,
right there.
Everyone-
I was like an idiot.
Everyone
for
with
the whole
either,
class.
I don't care which arm you use, everyone point, you're your own unit circle right now.
Wait, so is our circle this way or
Our
this
circle
way?
is this way. Our circle is this
I
way.
guess I can't go that way.
All right, ready? Everyone point to 180 degrees. Oh, you guys are good. Okay, 270 degrees.
It's like down
Oh,
here.
I don't know.
Yeah, it's like on this.
Pi over 2 degrees.
Oh, it's like
Pi over 2
straight
radians.
down.
What the hell's pi over 2?
Pi over 2 radians. Look up here. I have the
radian.
answers up here.
Pi over 2.
Where's pi over 2? Everyone point to pi over
Oh,
2.
cool.
There it is. Pi over 2. Everyone point to 5 pi over 6.
5? Like.
Hopefully, if you did this in Germany, maybe they'll think other things. Everyone point to 7 pi over 6.
7, 5, or 6.
What is it? What?
7 pi over 6.
About yonder. Yonder.
Everyone
Oh,
point
nice.
to 330 degrees.
Do you like cashews?
Now, this is going to be interesting. Everyone shut your eyes. Close your eyes.
Get
Oh,
in frisky.
No peeking. Nice and shut. I'll make you turn around if I think that you're cheating. Everyone point to 90 degrees. Then down. Okay. Everyone now point to, let's try a hard one, pi over 4 radians. Jaden, you're peeking. Pi over 4. Take a guess.
Am I wrong?
You're wrong, yes.
Oh,
Am I
it's this
wrong?
way. Really, right hand up.
Now you have permission to open your eyes. Where's pi over 4? Did you get it right?
I didn't know what to do.
Yeah, I got it.
All right. Close your eyes again. Point to pi over 3. Is it the up one or the down one? Now open your eyes.
Let's go,
Yeah.
Chad. Let's go, Chad.
Nice. All right, let's try a hard one. Are you guys ready? Close your eyes. Let's see if you can get this. I think you guys got this. 4 pi over 3 radians.
Oh my god, I'm trying to get this wrong. Is it up here?
4 pi over 3 radians.
I don't know.
And open your eyes.
Yeah, that's right.
Let's go.
Yeah. Oh, okay.
Down more than up. Remember, whenever I'm doing something divided by 6, I'm between here or here. I'm a tight little stroke butterfly. I don't know what you want to consider this thing. But if I'm going to be divided by 3, giant sweeping, I'm going all the way to the top, all the way to the bottom. Divided by 3, really close to the bottom, really close to the top. If you actually do this with your movement of your body, it's easier to memorize. I don't know if there's research that backs that up, but it is for me, so if it's for you. All right, everyone still up. Close your eyes. Close your eyes. Everyone point to, close your eyes. Everyone point to 300
She
degrees.
goes wheezing.
Three-
She's wheezing.
300 degrees. Where's 300?
Right
It's
here.
60 less than 360.
Right here.
Whatever that means.
Close your
Open your eyes. Where's 300 degrees? Ellie, you might have to sing you
Shut
up
up.
to let you come down. That's okay.
Jeez, you're just wheezing.
I'm good.
300 degrees. So, what I want you guys to do, since we're still trying to learn these, is tonight, for your additional homework practice, and I'm not going to be able to check this is not going to go into areas, I want you to go through these. You can just invent one. You know they're divided by 6, divided by 4. Just say, okay, 7 pi over 6. 7 pi over 6, and then you do it. 7 pi over 6 is right there. Try doing, I'm going to call them more dance moves, I guess. Try doing these dance moves more and more and more. There's a lot of them to memorize now. It's not as easy as positive even, negative even. These dance moves are way, way harder. All right, you can sit down.
Can you give me another voice crack?
We should record that. Oh, it is being recorded. We can go back and replay that, right?
Replay?
We'll replay it later. Okay, anyway, you should have both your degree locations and your radian locations memorized, maybe not perfectly, but at least roughly by today. Now, on top of that, I'm going to do the following things. Cosine of 45 degrees. And you're thinking, okay, everyone now, you can stay seated, but everyone point to 45 degrees. Remember, whenever it's
Move again, Mr. Sindel?
45 degrees. It's right there. Okay, now think about that. What type of triangle did you just make? Did you make it 30, 60, 90 or 45, 45, 90? There's only one number that you have to remember for 45, 45, 90, and you guys will all shout out, it's
Root 2 over 2.
Pi over 4.
remember, and I have this in the notes. If you don't have it written down, write it now. The only number that you need to remember from a 45, 45, 90 triangle is square root of 2 over 2. It can be positive or negative, that's it. So if I'm pointing down or to the left, remember that those are negative. If I'm going up or to the right, those are positive.
Wait.
So it's just root 2 over 2.
The answer is just root 2 over 2.
Oh,
And we're done.
That's what I said.
that's good.
So I come back down here and I say cosine of 45 degrees is the square root of 2 over 2. Let's do sine of 30 degrees. Before you even think about sine or anything, point to 30 degrees. Is it here, here, here? It's somewhere in that first quadrant,
Oh, that's bad.
30 degrees. Okay. What type of triangle did you just make? Okay, what are the two numbers that you have to have memorized for 30, 60, 90?
3 over 3.
And 1/2. Okay, now is the question that I have to ask. Sine, is that the x or the y coordinate?
Oh,
Y.
the Y.
The y coordinate. So I'm talking about the height. So if the height is small, it's a half. 1 is a tiny number. If it's big, then it's going to be square root of 3 over 2. Square root of 3 over 2 is bigger than a half. So is my height big or small if I'm pointing out to the right and a little bit up? What is my height? Height is small, now my height is big. Height is small, height is big. Small is 1/2, the answer here is 1/2. I'm doing these every single time in my head. I've just done them hundreds and hundreds of times, so I have them on recall.
Oh my gosh.
So this is 1/2.
Do I get hundreds of times?
You're gonna need to do it quite a few times. I think I take longer than most people to learn things. Luckily I work really hard and I can make it appear that I'm smart. I really just work hard. 60 degrees, everyone point to it. 60 degrees. 60 degrees is right here. What type of triangle did you just make?
Big.
Oh, 36.
30, 60, 90. And everyone shout out, what are the two things that you have to have memorized for a 30, 60, 90?
A half.
Square root of 3 over 2.5. Now, which of those two is it? Cosine. Is that asking for the x or the y coordinate? You guys will all shout out the x coordinate. So think about how much I've moved over from the from the y axis. How much to the right did I move? How much in the x direction did I move? Did I move a small amount or did I move a big amount? Small. Small is therefore 1/2. Cosine of 60 is 1/2.
There's no way we're gonna finish this. There's so many problems. Is this homework?
No. Your homework is far, far easier than this.
Cool.
They'll give you like 4 problems somewhere from this list and you're done. I want you to know all of them. I want you to have them on recall. If you plan on taking any higher level math, pre-calculus, AP calculus, you have to have these memorized. I can't tell you how frustrating it is for students to go into, especially AP calculus, and the answer is like cosine of 7 pi over 6, and you don't get credit because you don't know what that is. Or you have to spend 2 minutes solving that when you should just have that on recall. So if you plan on taking higher level math, this is very, very important. If you're taking Algebra 2 and you're calling it quits, then it's not as important.
I'm gonna keep these
All right, so sine of 60 degrees. We already pointed to 60 degrees. Point to it again.
Throw away at the end of the year.
Point to 60 degrees again.
notes.
It's not straight up, it's a little bit to the right.
It was not straight up.
So,
Hey.
okay, I'm doing sine of 60 degrees. It's not 1/2, it's the other measurement for a 60, 90, 30, which is, a few people said it. Square root of 3 over 2. You're only going to learn these if you practice and practice and practice. That's why I gave you a giant thing of stuff to practice. Try doing it without looking at the front side. You're doing this whole procedure over and over again. Where is 135 degrees? Well, it ends in a 5. That means it's going to be right in the center there, center there, center there, center there. Anything that ends in 5 is right in the middle of that coordinates, or right in the middle of the quadrant. So 135 is less than 180 and bigger than 90, so I'm pointing up to the left. Now, the question for you guys. What type of triangle did you just make? You guys will all shout out. It ends in 5. It ends in 5. 45, 45, 90. If it ever ends in 5, or if it is ever divided by 4, those are 45, 45, 90 triangles. I will say that once again. If it ever ends in 5 for degrees, or if I'm dividing by 4 when you're dealing with radians, that is 100% of the time going to be a 45, 45, 90 degree triangle. So this is a 45, 45 degree 90 triangle, but, okay, so there's only one measurement that you have to have memorized. Everyone shout out. The measurement that I have to have memorized for a 45, 45, 90 is...
Root 2 over 2.
There it is, square root of 2 over 2. But there's a problem here. I'm asking for cosine. Cosine is the x coordinate. I am not moving right, I move left.
Oh.
Left means I'm doing,
Negative.
the answer is negative square root of 2 over 2.
Do you have to make it into a bar or do you have to take them out?
Say again?
Do you have to make it into a bar or do you have to take it out?
You have to take all pieces apart.
Okay.
All right, so I've showed you the process of how to solve each of these. I am expecting you to either be maybe doing this mentally, but the way that I always do it whenever I'm first doing this is be okay. Like you might have to get away so you don't smack Beverly in the face as you're trying to figure out that, oh, 0 degrees is whoosh, right there. So be moving your arms. If you actually are using your physical bodies, using your fingers to count, it helps you with your mathematics. I do have research to show that. I remember the fingers. I don't know about the arms and trying to do the angles, but doing fingers with math does help you learn the math. I am assuming arms are going to be the same thing. Try to point to your angles. All right, good luck. Try to do this whole chart.